All right, 12.4 volumes of prisms and cylinder. Easy stuff, base times height. So it all comes back down to the assumption as to what volume even talking about. It's talking about a cube. You've got some kind of side times side times side, and that's everything breaks down to how many cubes fit in something. That's why we call this a cube. First thing I want to start off with is example number 1, where we have a composite figure, noting that this is 3 rectangular prisms, or even more if you want to find those out as well. So to find this out, you would just count the number of cubes. We have our formula for the volume of a prism, and it's just length times width times height, because that's the number of side lengths of a square, and then a square times the height is a cube. So you could just do 2 times the other 2. So this has 8 units cubed. This one's 7 times, this is 1 high, or excuse me, 7 units is a total. This is 1, 2, 3, 4. So this is 4, 1, and 2. 4 times 1 times 2 is 8 units cubed. And this last one is 1 by 2 by 2. 2 times 2 is 4 times 1 is 4. So this is 4 units cubed. You just add those up. 8 plus 8 is 16, plus 4 is 20 units cubed. All right, volume of a prism, area of the base times the height. You find the area of the base regardless of what the base is. If it's a rectangle, rectangle. If it's a pentagon, find the area of the pentagon. Or whatever it happens to be, take that and you multiply by the height. Very simple. Notice this formula is exactly the same, except that this time we're talking about a circle. This stuff is easy. Capital B is just the area of the base. Draw these in your notes and write this down so that you have it to reference, but these are in your formula charts. So if I need to find the area of this trapezoidal prism, I would just find the area of the base. The base in this case is a trapezoid. 1/2 base 1, that's the segment base of the trapezoid. I'm going to call that base 1, 14. The other base is 6 times the height, which is 3. The height of the entire figure is 5. Let's go ahead and find the area of the base. Notice this is 14 plus 6, which is 20, divided by 2, which is 10, times 3, which is 30. This is the area of the base. Base times the height is the volume. So volume is equal to 30 times the height. The height is the distance between the two bases. 5 times 30 is 150 centimeters cubed. Alrighty. Same thing over here, except we're talking about the volume of a cylinder. Remember, the volume is base times the height. The base in this case is a circle. So pi r squared times 6. Whatever this is, just plug and chug. Easy stuff. All right, volume of a cube. It tells you what the volume is. Well, the volume of a cube is x cubed times 90. Most of you guys aren't familiar with how to solve this in your calculator. I would like to show you how. You would take x and you would do 90, raise it to, probably should show it from a geometry way, not an algebra 2 way. You would press math. By the way, this is cube root of 90. To undo this, you would do the cube root to both sides. In the calculator, you would press math. I should probably get a calculator in front of me so I can say it appropriately. And it's number 4. You would actually go down to the 4th one and press enter, and then type in 90, and then enter. That's what you would type. And it would give you the value. The value that I get is, let's see, cube root of 90. It's 4.48. And this is inches. All right, I think I'm going to skip the guided practice for now. I might talk about it in class. I want to talk about Cavaleri's principle, noting that the height is the perpendicular height off of the side. So this would be the perpendicular height. And that is the height used in calculating the volume. Find the volume of the oblique cylinder. Notice the height is given to us. This is simply base times the height, but the height is the perpendicular distance off one of the bases to the other base. So this is just pi r squared times the height, 7. That's a plug and jug answer. I'll skip that one because I think it's repetitive. Oblique stuff, same thing as before. Do want to talk about this one though. Notice this is the volume of the triangular prism minus the volume of the rectangular prism. You would just find the values of each. Noting that finding the volume of the triangular prism would require you finding the height of that triangular prism. Well, we're going to have to, this tells you that this is equal to this, which means it's 3, which means this is 5, hold on one second. It would be great if I read my directions clearly. This is a arrow going to this segment. This is 10, this is 10, and this is 10. That means this is 5 if I drop this down. And this is a 30, 60, 90 triangle, which means this height of the triangle is 5 root 3. Just find the volume of the triangular prism and subtract away the volume of the rectangular prism. Alright, same thing, just break it apart into composite figures like that. I would probably break this up like this. I would find the volume of the total prism like this. And then I would subtract away these two prisms right here is how I would do it. Same deal, volume of the prism is just the area of the base times the height. This stuff's easy. If I got the hexagon, I would just need to draw that hexagon again and find the area of that base, remembering that this triangle's here, and 7.5 is one of the side links. Remember that a hexagon, this is 60, that makes this 60 and 60 as well because these two segments are congruent, which means this is equilateral, which means this is 7.5, and you can find the height using 30, 60, 90 triangles. Cylinders, easy stuff, just working with the formula. Working with variables, remember that x cubed is equal to 1,000. You're looking for the number that multiplies by itself 3 times to get 1,000. Well, that's 10, because 10 times 10 times 10 is 1,000. If we have a block of cheese and we need to find x, I think I'm going to skip this. Not feeling very well today. That's it for this video.